Hello students. So we already discussed some numericals based on law of conservation of mass and law of constant proportion. So now we'll move ahead in the chapter measurement of matter, and today we'll discuss about the atom, his size, mass and valency. So now first important question is like, what is atom? First I would like to just, so that you can make proper notes, I'll just put this here and then I will explain you in detail things about it. First, just read it out. An atom is defined as the smallest particle of an element. This you know because this was the Dalton's theory of atom, which you have studied in your previous class. And if you have any doubt regarding that, so please let me know. We can discuss that also. So an atom is defined as the smallest particle of an element. So what is element? In element, all atoms are made up of similar atoms. When they come together, they make an element, and which may or may not be capable of free existence. They may or may not be. We'll see some examples. However, it is the smallest particle that takes part in the chemical reaction. So it is the atom which actually takes part in the chemical reaction. Now let's see some examples. Like for example, atoms like low of noble gases like helium, neon, argon, krypton, xenon are unreactive and can exist in free state. So what exactly it means? Basically, it means that this helium can exist individually. Neon can exist. This atom can exist individually. However, atoms like hydrogen, oxygen, nitrogen, etc. are highly reactive and they do not exist in free state. They always need one more atom together to exist. They can't exist alone. That's the reason you will never find hydrogen. It is always in gaseous form, H2, O2, N2. Always two atoms are coming together, and they exist in the combined state with atoms of the same element or atoms of the other elements also. They can exist, like for example, they exist in dihydrogen, as I was telling, dioxygen, dinitrogen, or combined with other elements. They may exist like hydrogen chloride, HCl, water, or ammonia, NH3, etc. So the second part of the definition implies that the whole number of the atoms and not the fraction of atom take part in the chemical reaction. So just to make it more clear, what it exactly says that this, all these noble gases, they are like helium is there, neon is there, argon is there. So you will see they exist individually. They, because why? Because they are unreactive, hence they stay in free state. This is their free state. They didn't need any other element. This, they can stay like this. While as what it exactly says, the other like which are highly reactive. And what is high reactive? Like hydrogen is there, and then oxygen is there, and then nitrogen is there. So they don't exist individually. They always need one more hydrogen atom together. Oxygen to exist, it needs one more oxygen atom together, then they can exist. So this makes it H2, this makes it O2, like that, N2. So I hope you're understanding it, because they are highly reactive. So they don't exist individually, they always exist in pairs, or they are not in pairs, or they can exist in if with other elements they can also exist. Like hydrogen can make bond with chlorine. So this means hydrogen chloride. But individually, it's they can't exist because they are highly reactive in nature, highly reactive. And so they don't exist in free state. So this is the first point regarding what is an atom. So atom is the smallest element, may or not be capable of free existence. However, the smallest particle is that takes part in the chemical reaction is atom. So this is all about the atoms. So let's move ahead. So many of you may be wondering, like, then how atom looks like. You will be surprised. like what we represent in our textbook, like this atom. My dear friends, atom, this is not the way exactly atom looks like. This is just a representation we do. If you see exactly what atom is, this is the image. So atom are extremely small particles. They are extremely small, so small in size that they cannot be even seen under microscope to imagine about their size. So it is interesting to mention here that if a millions of atoms are stacked on one another, the the thickness produced may not be even equal to the thickness of the sheet of paper. So that is the atom is so small you can't see it even in microscope also. However, recently high sophisticated microscope known as scanning tunneling microscope STM have been devised, which has made it possible to take a photograph of atom. And this is how the you can see this photograph atom looks like. So this is atom, you can see these are actually 48 iron atoms which are kept on the surface of a copper crystal. So this is how the atom is, this is the atom. But for the ease of representation we represent it like this. And obviously it has some radius, it has some everything, but it is this is the way. These are 48 iron atoms, arranged on the surface of copper. So this is how it looks. This is how atoms look like. And then and as atoms are considered to be sphere, that is what I told you. They are how we represent them. This is the way we represent them we represent them as a sphere. This is how we represent them. So the atoms are considered to be spherical. We consider them, but exactly how they look like as I showed you in previous image. So, but we represent them as a sphere. Obviously, when we represent them as a sphere, that means what? Their sizes are expressed in terms of radii, because they are. If we are representing them in a circle, obviously we have to. There has to be some radii to it, and this is called atomic radii. That radii is called atomic radii. So atoms are so small in size that their radii are usually expressed in nanometers. Nanometers, very small, and their radiuses are of order 10 raised to minus 10. And if you see, this is the this is the graph which is given at page. This is the table which is given in your page number 48 of your textbook. You can please open it and refer it. It shows that atomic radius in meters, like 10 raised to minus 10 is the hydrogen atom size, 10 raised to 9 is water molecule, then 10 raised to minus 9 is hemoglobin molecule. And it also shows the relationship, like how 1 by 1 10 raised to 9 meter is equal to 1 nanometer, or you can also say 1 meter is equal to 10 raised to 9 nanometer, or 1 nanometer is 10 raised to minus 9 meter. This is how we can also represent. And for example, hydrogen, which is the smallest of all atoms, has a radius of 0.037 nanometer. So this is, and now obviously some of you may be thinking how the atom looks like, because we know matter is made up of molecules, and molecules made of atoms, and this atom is further made of proton, electron, and neutrons. Protons, neutrons, and electrons. And this is very important to understand. And this is something how it looks like. It looks like this. You can see here, protons and neutrons are in the center, and it is known as nucleus, and the electrons keep revolving around it. So this whole is in atom, and in this atom there are like three subparticles, which is proton, neutron, electron. Because further we are going to discuss about the atomic masses, so it's very important at that time to know what is the mass of electron, what is the mass of proton, neutron. Then only we'll be able to calculate the whole mass of atom. And now we will move ahead of our presentation. Now we will discuss about the symbols. What about the symbols used to represent the atoms of different elements? We already have a discussion on what atom is, how big are the atoms, what is their size, and then we saw STM image of 48 iron atoms on a copper crystal. And now we come to the next topic, which is the symbol used in representing atoms of different elements. So basically, symbol is a short method of representing anything. It may be representing by figure. You might have seen, on when you are, if you are driving, or if you you see driving signs. There's a like board like this. Sharp U-turn is there, or trespassing is not allowed there. So all these things which are there is basically what exactly they are like, telling us some signs. So, and they can represent by light, or letter, or by figure. So in case of elements, symbols mean a short method of representing full name of element. मतलब you short method of representing full name of element. So first person who started this was Dalton, symbol of elements. What Dalton was the first scientist to suggest specific symbols in terms of figures of different elements known at that time. In fact, the symbol used by him also represented the quantity of element, one atom of an element. A few of these symbols, as proposed by Dalton, are as like if you see hydrogen, he places one dot in that, or you see phosphorus like Mercedes sign, and then copper, lithium, he just circle and he has writing the first alphabet in that. Iron, sulfur, and mercury. You can see how he has made it. Gold, sulfur. So, but problem like it was not, it was very complicated, and it was inconvenient to draw all these uh, you know uh, elements, all these signs. And obviously at that time when he did it, that time there were a very few elements were known. So even that it may be possible to draw like this, but when the elements started, now we have 180 elements started getting discovered one after another, so it was very difficult to every time represent short forms in this fashion. So at that time, there was one more Swedish chemist, Berzelius. His name was Berzelius. He suggested a more scientific method for representing full name of an element by one or two letters from the name of element. So he was the first person who suggest, like, okay, why don't we just, what is the name of that element? We can represent first letter, or first two letters of that element, and it actually clicked. So the modern symbol of elements is actually the gift of Berzelius. So with that, we'll study in our next lecture. Thank you very much. Hare Krishna.